Right, today we're going to have a look at some Band 1 questions from the semi-final. Hopefully this will give you a bit of a snapshot of what to expect in the final in April or for those competing in the next challenge in September. Best of luck. We have a tricky question from the Band 1 semi-final here today. We were given this quadratic, we were given two coordinates that are on the quadratic, and what we need to find is the sum of the coordinates of the x-intercepts. So where this quadratic cuts through our x-axis. So if I was to do a bit of a sketch and look at these points, 6 minus 2 I'm going to say is here, and 7 minus 2 is going to be here. I reckon the quadratic must look something like this. That sort of helps me see the quadratic. Okay, so we need to find out what B is and we need to find out what C is. That's two unknowns, but I reckon we can make two equations. First things first, x coordinate, y coordinate. Let's substitute them in. So my first equation, minus 2 equals 6 squared is 36 plus 6b plus c. Okay, let me rewrite that equation then. That will be 6b plus c equals minus 38. That is my first equation. Now, let's make another equation. Again, minus 2 should equal 7 squared, 49, plus 7b, plus c. Okay, let me rearrange the equation to make it nicer. So 7b plus c equals minus 51. Okay, so I have now made two equations, two unknowns. Now it's your skills of simultaneous equations. I'm going to subtract that equation away from that equation, which 7b subtract 6b is b. C subtract c, gone. We've got rid of the c. Now minus 51 minus 38. Yes. What does that get us? Be careful now. Minus 51 minus 38. That will give us minus 13. Okay, so we now have our B value. Now, I reckon from my crude diagram, the C value should be positive. Let's see if it is. Okay, let's substitute minus 13 into my first equation here. So 6 13s is, or negative 13 is minus 78 plus C equals minus 38. C has to be 40. Okay, so I knew C was going to be positive, but my diagram is a bit off. But there we go. Now we have B and now we have C. So the equation, our function, our quadratic function is y equals x squared minus 13x plus 40. Okay, I think we might be able to get everything on this board here today. If we're looking for the x-intercepts, and we need to find the sum of these x-intercepts, you know what to do. We have to let this equation equal 0, solve it, and I reckon we can solve this by factorizing. So let's put it into brackets, let it equal 0, x, x. Okay, I need a factor pair of 40 that adds up to negative 13. There's only one factor pair I can think of. That would be x minus 5, x minus 8. Minus 5 times minus 8 is 40. Minus 5 add minus 8 is 13. So that tells me my x-intercepts are 5 and 8. So this would be 5 and this would be 8. Hence, we need the sum of our x-intercepts. Easy bit now. 5 and 8 is 13. I hope you guys got that. Another question from our Band 1 semi-final. Right, we just have to take our time with this one. Students often rush in and sometimes confuse themselves. We have a quadrilateral here, ABCD, and we've got some information. We can see here the angle BCD is a right angle, 90 degrees. Never assume an angle is 90 degrees unless you actually see the signal that it is. Now we've got some information, okay, so we can start looking through these clues. Angle, so ADB is 1/3 of DAB. Okay, so if I was to call that x degrees, that's DAB, angle DAB. Angle ADB is 1/3 of that. So that should be 1/3 x. I'm going to leave that there for now. Okay, ABD is 1/3 of DBC. Okay, interesting. We will park that for a moment because a lot of people may assume that ABD and BDC are the same angle because it looks like a Z angles, but there's no indication that these lines are parallel. Okay, next one, BDC is 1/2 of DBC. Interesting, this should be easy enough now. But we know this is 90 degrees, so these two angles have to add to 90. And if BDC, this angle here, is 1/2 of DBC, okay, we've got a ratio here of 1 to 2. And we know there's a total of 90 degrees for these two angles. So 3 parts 90 degrees. This angle here should be 30 degrees. And hence, this angle up here should be a nice, easy 60 degrees. Now let's go back to clue number 2. ABD is 1/3 of DBC. Brilliant. So now we know that this is 20 degrees. Nearly there. Now we can make a nice, easy equation. How much have we got left over? We have 160 degrees up for grabs in this triangle. And we have x plus 1/3 x must equal 160 degrees. Okay, if we add these all together, we've got 4/3x equals 160 degrees. Cross multiply the 3, 4x equals 480 degrees. So x must equal 120 degrees. So here, what's left over for our angle down here? We're looking for DAB. We've already found it. It's 120 degrees. That one down here obviously would be 40 degrees. But there was our answer, 120 degrees. Just go step by step through all the clues. Make sure you understand the question. Another question that featured pretty early in the Band 1 semi-final was this one here, where we were given a square ABCD of side length 10 centimeters, meaning all sides of the square are 10 centimeters in length. Now we were given some information to say AE was 7 centimeters and BF was 4 centimeters. Now this question was just looking for the perimeter of the pentagon AEFCD. Okay, so we've got some sides that are pretty straightforward. We know this side is 10 centimeters, that side is 7, and then this side here must be 6 centimeters. So really the tricky bit was this diagonal style line here. How do we find that? And we're going to call on our favorite Greek, Mr. Pythagoras himself. We know here's 4 centimeters, obviously a right angle here because it is the corner of the given square. And this length here must be 3 centimeters. So I feel a famous Pythagorean triple coming up. So to find EF, we'll use A squared plus B squared equals C squared, where A will be 3 squared plus 4 squared equals our EF squared. So this 9 plus 16 equals EF squared. EF squared equals 25. EF must be 5. Okay, 5 centimeters. So let's add everything up. 6 plus 10, 16, 26, 33 and 5. We have a perimeter of 38 centimeters. Just go through it step by step.